All right. So for this first problem, one of the first things you'll notice is we have the amplitude and you have the stuff on the inside. So it's not being shifted left, right, up, down, or anything like that. So I know that this is going to be 3/4 and negative 3/4. This is going to be a 0. And all I got to do to figure it out is put the 2/3 pi. Remember that this is tangent. So the period is pi, not 2 pi. So pi, and then I multiply by 3/2. When I do that, I get 3 pi over 2. There you go. So I know that my period is 3 pi over 2, which means that each quarter is going to be 1/4 times 3 pi over 2, which is 3 pi over 8. All right? So that means this is going to be 0, 3 pi over 8, 6 pi over 8, but 6 pi over 8 is just 4 pi over 3, or 3 pi over 4, 9 pi over 8, and then 12 pi over 8, which is 3 pi over 2. Right. So I have that, and I know that this is tangent. So tangent has the asymptote down the middle, and then the two dots here and here, dot here, dot here. So that's my graph. Now I just got to put it in context of the graph down here. So I know that this is 3/4, negative 3/4, and I'm just going to go in order. Why not? So 3 pi over 8, 3 pi over 4, 9 pi over 8, 3 pi over 2, and there's my box. And so I know that there's an asymptote down the middle. All right. And then from there, I can just recreate the pattern. The box happens to be 4 across. So I know that here's 3, 4 across. 1, 2, 3, 4. All right, and I can continue the pattern. So I know that this is going to go down here. We're going to have a vertical asymptote. And now you can kind of see the shape. Notice that it's just dot, dot, dot. And so now I can continue that pattern. Dot, dot. There you go. And so, again, this is negative 3 pi over 8, negative 3 pi over 4, negative 9 pi over 8, negative 3 pi over 2. So technically we're done. The actual part of the graph that they wanted was just from negative 3 pi over 2, 3 pi over 2. But we can keep extending the graph as much as we want, especially if you have the room to do it. Anyway, I'll just stop there. All right, so there you go. That's the answer to that one. Hopefully you got that one right. So let's go to the next one. Graph 5 cotangent negative pi over 3x plus pi over 2. And so this one's a little trickier. I gave you some more space for it. The first thing you got to do is notice that Here I can take the negative out on the inside. And so now that the negative is being multiplied, I know that this is an odd function. Odd function means the negative gets to pop out on the outside. So that was the trick for this one. Hopefully you caught it. All right. So again, there's no shift up or down. There's no plus k. So I know that this is 0, 5, and negative 5. Do I have to? Yep, I don't ask you for that stuff. And so now I just need to take the inside and put it between 0 and pi. So my first step is to add pi over 2 to each side. And so pi, which is 1 plus a half. 1 plus a half is 3 halves. You add the pi back in, 3 pi over 2. And so now I'm going to multiply by 3 over pi. So if I do that, the pi's cancel. I get 3 halves x, and then the pi's cancel. 3 times 3 is 9, 9 halves. So my period is going to be 9 halves minus 3 halves. 9, 8, 7, that's 6 halves. That's 3. So the length of each quarter is just a fourth times 3, or 3/4. So this guy right here, which I'm going to see if I can copy paste. This tells me that it's 3 halves, 9 halves, and then each quarter is 3/4. So if you want, you can get your calculator, and we can figure out what each tick mark is going to be. So 3 halves plus 3/4. You can math frac that. 9/4 plus 3/4. Math frac that. Oh, sorry, that's 3. And then plus 3/4. 15 over 4. All right. And so now we're dealing with, notice that this is an upside down cotangent. So usually a cotangent would go from here, here, and here. But we're not doing that because it's upside down. So it kind of flips around. It's going to be here, here, and here instead. The edges are still asymptotes. But my graph is going to look like a half parabola one way, half parabola the other way. Now I just got to put that in context. All right. So we run into a little dilemma just like last time, because if I put a 3 halves here as my first one, then I'm forcing that from here to here is 1.5, which means that this has to be 3, which means that this has to be 4.5, which means this has to be 6. And notice that it just, our graph ends up being a little weird. So it's up to you if you want to do it. But what I'm going to do instead, so our box, if we're choosing to make each tick mark 3 halves, notice it goes to from 3 halves to 9 halves, or 4.5. And so our box would look like this. where there would be, see how skinny it is? And it's up to you. If you want to keep it like that, that's fine. But I'd rather each tick mark to be an actual thing. So what I'm going to do instead is, instead of making each one 3/2, I'm going to make it what the actual quarter is over here. So 3/4. So basically, I'm making each tick mark worth 3/4 instead of starting at 3/2. If you start at 3/2, you're forcing each tick mark to be 3/2. My cat just knocked down the thing and everyone can see me. So hold on, let me pause the screen real quick because I don't want people like, what's that guy doing inside his house? All right, sorry about that. I don't want people peeping in on me. Cat's knocked down the curtains. All right, going back over here. So again, instead of starting, if you start at 3/2, then you're forcing each tick mark to be 1.5, which means that your graph's going to be really skinny. So instead, I'm going to make each tick mark worth 3/4. So my graph will be not too bad. So I have 3/4, 3/2. If you're wondering where I'm getting these numbers, it's 3/4, 6/4, 9/4, 12/4, 15/4, 18/4, 21/4, and I'm just simplifying when I need to. 12/4 is 3, 15/4, 9/2, 21/4, and then I repeat everything on the other side. Did I get them all right? 1, 2, 3, 4, 6. I missed one. Where did I miss? Oh, God. Okay. Bad Gilbert. All right. So 3/4, -3/2, -9/4, -3, -15/4, -9/2, -21/4. Okay. Anyway, so if I do it like this, then my starting point is at 3/2, my ending point is at 9/2. So my graph is from here to here. It's much more spaced out. And since I'm dealing with cotangent, upside down cotangent, I know that my graph is going to go eh, eh, eh. So upside down parabola, regular parabola, asymptotes. And we kind of repeat the process. It's going to go with an asymptote, and then an asymptote. There you go. All right, so if you have any questions on that, or hopefully you got it right, but if you have any questions on it, let me know. Now, the last question I had you do on your own was the very last one, number 7. So let's go ahead and jump to that one. Okay, so it says identify basically everything you can about this equation and then graph one cycle. So it says graph one cycle, but I'm going to basically graph as much as I can. Anyway, looking at this, our first task is to rewrite it. So y equals -3 cosecant pi x over 2 plus 3 pi over 4, and then minus 1. All right, so with that, what can we do? We know that this is upside down cosecant, which means that it's going to be, so upside down cosecant, which means that we're going to have to graph an upside down sine wave. That was the trick for this one. The very first time I did it, I got so into the habit of what I was doing, I did it wrong. Okay, I know that k is -1, and then I'm going to go up 3, down 3. So up 3 gives me 2, down 3 gives me -4. So those are the two values there. All right. And the next task is to put this pi x over 2 plus 3 pi over 4. Now, since this is cosecant, the period is 2 pi. So I subtract minus 3 pi over 4. So 2 minus 3/4 is basically, I'll just use my calculator, I have it here. So if you want, you can say 2 minus 3/4, math 1, 5/4. And so we end up with 5 pi over 4. Then I'm going to multiply it by 2 over pi. So that kills those out. The pi's cancel. And when the 2 over 4 is just a half, so we end up with -3/2 x. And then the pi's cancel, so 5/2. If you want to find your period, it's just 5/2 minus -3/2, which is 8/2, which is 4. So the length of each quarter is just 1/4 times 4, which is 1. So that's kind of nice. So I have my period, which is 4, length of the quarter, which is 1. Horizontal shift is just, it was 0, and then it moved to -3/2. So the horizontal shift is -3/2. My vertical shift, I'm going down 1. And let's see if we can create the domain and range. So looking at this graph, we can see that there's asymptotes at all the x-intercepts. So my first asymptote occurs at -3/2. Again, we're getting this part right here. Let me copy paste. So this is -3/2 to 5/2. Each quarter is 1. So -3/2 plus 1 is -1/2. Plus 1 is 1/2. I know it's kind of hard to see. Plus 1 is again 3/2. Plus 1 is 5/2. So the first asymptote occurs at -3/2, and the next one occurs at 1/2, and they're 2 apart. So that means my domain is x cannot be -3/2 plus 2k. Now my range, I actually have to graph my parabolas now. Everything feels like it's in the way. I apologize. Whee! Move that over there. So the range is everything up to the bottom. So -infinity up to -4, union, and then it starts up at the top again from 2 to infinity. Anyway, so I have everything filled in, so let's create this graph, and we are done. All right. So each quarter is 1. So I have 1, 2, 3, -1, -2, -3. And my first box goes from -3/2 to 5/2. So -3/2 is -1.5, and -4 to 2. So here's my box, all the way to 5/2, which is 2.5. Okay. And my sine wave, my upside down sine wave, went from -1 1, whoop, boop, boop. I'm just recreating the box that I have up there. All right, so I have my asymptotes. Asymptote, right down the middle at 1/2. Asymptote. All right, there would be another one over here. And I create my graph. So here what I have in red is the actual graph. All the other stuff was just tools to aid me in creating this graph. There you go. Again, the sine wave would continue. Yeah. And then right there. Did I get it? Yeah, 1, 3.5. Okay. So anyway, that is my graph. So hopefully you worked it out. The big trick here was that it was a flipped cosecant. So that was the tricky part. All right, if you have any questions, let me know. And hopefully everything went all right. Have a good day.